we are going to see the problem in unit 2 regarding the spring and bar assembly. Here the bar and the spring are joined together. We have to find out the displacements, reaction forces and the stiffness matrix. Stiffness matrix. So this for the bar assembly is shown, determine the nodal displacement, forces in each element, reaction. Here we have to find out the forces and nodal displacement, and here first of all you just make sure that this is self weight is neglected, and after that you find out the nodal forces. First you consider the self weight is neglected. Now we are going to find out the stiffness matrix of the problem, and everything is given. Since it is 2 meter, it is a gigapascal. I have converted that into a Newton per meter square, and all our stiffness matrix and everything is in stiffness matrix is 2000 kilonewton per meter. So I have converted all the units into 1 units, that is kilonewton per meter, and the length will be length and area will be in meters, that is area will be in meter square, length will be in meters. So first I am going to find out the global stiffness matrix of the bar. So this is the bar, this is the fixed bar, this is the fixed bar is fixed, and 1 2 3 it is problem, it is given 1 2 3. So we have to fix the nodes 1 2 3 and 4 nodes, 3 elements and 4 nodes. One is a spring element, other 2 is a bar element. The bar element length is given and 2 ends are fixed. So at this node and at this node the displacement will be 0, we know, and the P, the force P is acting at the node 2, that is how much it is, 8 kilonewton. Everything is given. So first what is the principle? We have to find out the global stiffness matrix. So first of all you just apply the global stiffness matrix finite element equation in each and every element. That is what I have written here. F is equal to K into U. This K is the stiffness matrix, AE by L, 1 minus 1 minus 1 1, and displacement matrix and force matrix. So first element is that the one end is fixed, U1 U2 are the nodes, and 8 kilonewton is acting. So thus I have find it out this equation, and applying it in this equation, apply the values of AEL and these equations I got. So I am going to multiply 7 inside. So I have multiplied the 7 inside and completely 7 inside, and again element 2. The element 2 is this one, element 2 is this one. So force is acting here, and element 2, this is U2 and U3. U2 and U3, 8 kilonewton. So again I am writing the equation, applying this should be F2 and F3. So all the A2 and E2, L2, L2 is 2, A2 is 6, everything is same. So no need of writing it's AE, which because the material is same. So this equations I got 7 minus 7 minus 7, 7, U2, U3 and F2, A3. Here I have written the nodes 2, 3, in reading I have written 2, 3 and 2, 3. There 1, 2 and 1, 2. So finite element equations of a 3. The third element is a spring. So the third element is a spring element. So the AEBL, instead of that AEBL, K I have written 1 minus 1 minus 1, 1, U3, U4, F3, F4. Now I am going to apply the equation K. The stiffness matrix is given, that K constant, the material constant, that is spring constant is given, that is 2000 kilonewton per meter it was given, it was I have written. So this 2000 10 to the power of 3 I have taken out and making this equation. So now I am going to, what is the next step? Assemble all the equations, 3 equations. I have assembled this. Here U1, U2, U3 for U1 and U4 are 0 because both ends are fixed. So U1 and U4 are, it must be 0. So 10 to the power of this 3 I taken outside, and everything. This is assembled 3 equation number. I got the stiffness matrix. Now at node 1, as I said, boundary condition U1 is equal to 0, U4 is equal to 0, F1, F3, F4 is equal to 0. This is body force is 0, not the nodal force, body force is 0. So the body force is 0. So I am going to take all those things, u1, u1, u4, f2, f3, everything I applied. So since u1 and u4 are 0, I have neglected the column, first row, last column and the last row, fourth column and fourth row. So I am getting this value. I am getting the algebra. From this I am getting the algebraic equation. From the algebraic equations you can find out the u3 value and u3 value and u2 value. This is what applied. This is what we have seen through. Now again they have asked reaction force. R is equal to K U star minus F. So from here reaction force is applied. The reaction forces, so stiffness matrix is this one, U1, U2, U3, F1, you know everything. This is the body force, F1, F2, F3. Now we have to apply all the values that you have found out in the previous pages. So I have applied all the values and now I am finding out the R1, R2, R3. So I am getting this values. I am getting after minusing it from the K, U star and minus and whatever the simplification I have done, and I got this. So this is the value. I am getting this R1 is 6.5, R2 8, and this one. This R2 is 8 is that, the 8 value is that is applied forces value. So this and this are support reactions are R1 and R4. This R1 and R4 you should reaction force at the support. So the reaction support at the support multiplied and that must be equivalent to this 8. Whether it is getting? Yes. So this and this you add it and you will get the 8 and this value and you will be getting 8 kilonewton is equivalent to 8 kilonewton. So this is okay. Verifications. The reaction force must be equivalent to the applied force in the opposite sign. So now we are going to find out the force in each element. The force in each element is the same finite element equation you have to apply from the previous. These are the values from the previous taken in that F1 and F2. From this I have from here itself we can find it out. We multiply this inside and you will get F2 and F2 equation. So from this F1 F2 equation, these are not body forces. Remember that these are not. This is the nodal forces. Never the body forces. These are all the forces. Because of that 8 kilonewton, it is distributed among the nodes. So that forces are I am now finding it out. It is not the body force. So please remember that F2 and F1 and F2. So I got so an element 2 equation, finite element equation. Again I have taken the same element of equation and I'll find out F2, F3 and element 3 equation. Element 3. This is the element 3 equation. I have made it and this is again F2 and F3. So I got element 3 equation. I got element 2 equation. These are all the forces of nodes, not the gravitational force. Please remember that. Okay. In both the forces, if you want to find out, the same finite element equation should be used to find it out. First, the self-neglect is neglected and find out the displacements. Next, you find out the F10, F. You don't give any nodal forces. Just write the nodal forces. The same equation you substitute, and you will get the 2 equations and 2 unknowns. So easily the algebraic equations can be solved. So don't confuse with body force and nodal forces. Nodal forces is due to the applied force, and the body forces the gravitational force. So force at node 3, node 4 and the result I have written. The result, complete result I have written. And one more point is that even suppose self weight is not neglected, even the body force is given. So even the body force and the nodal force you have to find it out. If the force, if they asked self weight is not neglected, they have asked for the forces, body force also and the nodal forces also, then you have to find it out. Thank you.